The objective of the session is to understand what is big data. I mean, big data is not just a pile of data, right? It's not just terabytes, petabytes, or exabytes of data. It's much more than that. And also, I'll also be giving you a brief introduction on what is the difference between traditional warehouse versus Hadoop. There is a case study on Sears, which I'll be walking you through. Also, why should I learn Hadoop and related technologies? I mean, I'm sure there are lots of you who might be in this industry for more than a decade. You might be working in one technology or the other. Let's say someone might be working on Java, someone on Oracle, someone on .NET for a very long time, and you know, it's but natural to ask this question: why should I learn Hadoop? You know, I'm already doing good in my job. So I'll answer that as well. Jobs and trends in big data. You know, you'll be very surprised to know that big data is doing extremely well. I mean, big data pays you the most in terms of salary. I'm going to walk you through that as well. Also, briefly, I'll be talking about Hadoop architecture and ecosystem. But you know, just to give you a side note, you know, I'll not be able to cover everything. This is just 1 hour session. But I will definitely be able to give you an insight as to what you should learn. You know, how you should be proceeding ahead with big data. So let's get started. Now, what is big data, right? It's we know, right? We know it all. It's lots of data. I mean, that's one aspect of it. But you know, but what actually is big data? I mean, is it just a lot of data, terabytes and petabytes of data? No, not exactly. I'm going to talk about there are actually four V's, right? Volume, velocity, variety, and veracity. I'm going to talk about that in a little time from now, but let's understand what is big data. Big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. Now, what does this mean? This means to say that, okay, let me give you a background. You know, we have huge information available around the world in various formats, right? One form or the other. Database is not the only source of information. You have internet, which is another source of information. You have satellites, which is another source of information. You have weather data. You have RFIDs, whatnot. I mean, just think of anything in the whole world, and that's generating data, right? How do we handle such data? Are those data stored in database? Certainly not. I mean, they're not even structured for us to be storing them into database. So, according to a report, it says that only 8 to 10% of the complete data that the world has is actually in database. And as we move along, you know, a year or so down the line, that's coming to even lesser. You know, the more we move ahead in time, the lesser the amount of data would be stored in database, because it's not actually possible to store so much of data in databases. I mean, when I say databases, I'm talking about RDBMS database like Oracle, MySQL, you know, just name it. You know, DB2, Teradata, whatever. Just name it. It's not possible for us to be storing so much of data in any kind of databases, and hence we need big data. I'll talk about big data databases as well a little later. What are the challenges with all this unstructured data which cannot be stored in big data? It's how do we capture those data? How do we capture data from RFIDs? How do we capture data that the satellites or even the Mars robo, you know, hover, whatever robots are generating? How do we capture all those data? That's the biggest challenge. How do we curate those data? How do we cleanse those data? There are a lot of additional data that are being generated out of this data. I mean, you might, in 100% of the data that is being generated, let's say 20% is useful to you, and 80% might not be useful to you to whatever analysis or machine learning or whatever analysis that you are doing on the data. You know, how do you cleanse those data? That's a big question. Where do you store so much of data? Terabytes, petabytes, exabytes of data. How do you store it, and where do you store it? How do you search for a pattern in so much of data? It's not in database. You just cannot select star from the data, right? That's not possible. So how do you search? How do you share those data? You know, what medium? Would you be able to download terabytes, petabytes, and exabytes of data using internet, right? And how? And finally, you know, the biggest question of all: what do you analyze? How do you analyze? What is it that you're trying to look into? So the biggest problem with big data right now is you have data. You have everything with you. As of today, we even have the processing power, but we do not know what the problem statement is. So first question is, what do you want to analyze? People will just dump huge data on you and then say, just analyze it for me. They will not even give you a problem statement. So your job as if you are a data scientist or data analyst or whatever you are, would be to look into the data, first of all find the problem statement, and then go ahead and do analysis and visualization. So that's a lot of task. And this is just to give you an idea as to where the data is coming from. The data is coming from the cloud, the data is there in database, you have to analyze those information, the data is being processed from mobile, there are terabytes of data, you have SQL, no SQL, so on and so forth. Let's peel that layer by layer now. Okay, now I was talking about unstructured data, right? What is unstructured data and what is structured data? Let me give you a high-level understanding of what is that. Structured data are those data which we are able to insert in a database or which we are able to store in database. So structured data are those that are those data which you'll be able to retrieve from database using your select star query. Because at the end of the day, be it SQL, MySQL, Oracle, DB2, whatever databases that you take, at the end of the day, SQLs are same. You'll be able to do a select star and then you'll be able to fetch data. So all those data which you are able to fetch and insert into database or fire select star on that are structured data. And all those data which are not in any database, let's say for example, the text files, right? Or the data that is there in the internet, the blogs that you write, or for example, the newspaper data. Are they all in database? No, they are not in database. They are stored in certain format, but they are certainly not in databases. So they are all unstructured data. They are RFIDs, the weather information, the data that is being generated by submarines or spaceships, etc. They are all unstructured data. And look at this graph. The amount of complex and unstructured data is so huge, and only so much is your structured data, right? And then it has been exploding. From 1970s, there was no unstructured data. Maybe it was there, but it's just that we were not storing it. 1980s, still no unstructured data. 1990s, we started having more of relational data. That is when the data explosion started taking place. By mid 1990s, you see there is start of the complex and unstructured data. By 2000, it just started exploding. And then look at the exponential graph. So the challenge is not here. Yes, it's not that the challenge does not lie here at all. We have challenge in this portion as well on the relational data, but the biggest of all challenges lies here on this part, wherein you will be analyzing, cleansing, and finding a pattern or doing analysis on the complex and unstructured data. So just look at this 2,500 exabytes of new information in 2012 with internet as primary driver. That was in 2012. The same amount of data would have been, we are generating it every year right now, and even more than that. Digital universe grew by 62% last year to 800K petabytes and will grow to 1.2 zettabytes this year. That's huge data. Just count the number of zeros and you will know as to how huge this data is. Now, challenges, right? The increasing data volume is a big challenge, and new data source and type. All of us must have an account in social media. Who does not use Facebook and Twitter these days, or LinkedIn for that matter, to search jobs, right? Everyone does that. And look at the amount of data that we are pushing in Facebook every day. You push images, you write text, you chat with people, whatnot. You publish so many things in your timeline. Look at the amount of data that you are just pushing in. You can store your entire, picture there. How much ever you click, we generally share it on Facebook these days, right? Look at the type of information that you are storing here. Pictures, text, and so many other things, right? It's just that it's not just in one format. And even if you had to store all of them in database, they would require tens and hundreds of different types of databases. Look at Twitter. Every second there are thousands and thousands, or I would say millions of tweets being written. Look at LinkedIn. I mean, everyone has that account in LinkedIn, and the information just gets piled up. You know, no one is deleting anything from anywhere in the internet. It's just being posted and it stays there. I mean, how many of you remember having an Orkut account? You would have had Orkut account, but Orkut just went away, this year, I guess, right? But how many of us deleted those accounts actually by going there? I mean, how many of us deleted those pictures? They're all there. Although Orkut is out now, I mean, they have shut down the server, but then those information were lying in the internet for a very long time, right? So that's the source of data. Social media, even the transactions on OLTP applications have been increasing. There are newer applications coming every day into the market, be it for insurance, banking. There are better and newer things coming up every day, which are generating tons and tons of data. You have emails, you have CSVs, you have PDFs, you have XMLs, you have various types of machines, mobile. Everyone uses smartphones, and every time you might be scribbling something on your mobile. You might be sending text SMSs, you might be chatting on WhatsApp. Where are those information stored? It must be stored somewhere, right? So the challenge is big data is here, right? And that's okay. I mean, the bad news is that we are struggling to store, process, and analyze the data, and the good news is big data is here. Now, what do I mean by big data? I don't mean big data as in there's huge data. I mean, there are tools and technologies available today to go ahead, process this data, find a pattern and meaning out of all this. How many of you have done this? You would have installed some application and then say, you would have downloaded some application and then even before reading it, you say allow, right? And I agree to the terms and conditions, and then you say allow. Most of those applications might be, they would have something like this, that I would scan your logs and then try to find out all this information. Many applications do that, and everyone might do every e-commerce websites or every application that you download, they would have some information or other about you. I mean, your information with the advent of big data is being stored at record level. Every information, every Tom, Dick, and Harry would have one record for himself or herself in each of these individuals or organizations' database, and that's how you see a lot of information being exchanged, right? People buy and sell information. It's either for advertisement or for any other good or bad reason, right? There's a lot of exchange of information. You might be receiving a lot of all this ad-related calls saying that, sir, do you want to buy this product, or or for that matter from job websites, right? They might be like, sir, we have jobs for you. I'm sure you must be receiving those information. Where are they getting your number from? Maybe you would have provided that in one of those jobs website or somewhere. But even if you have not, even if you are very careful, let's say you buy a new mobile phone, a new SIM card, right? Even then, after a few days, you start receiving that. How does that happen? It's really intriguing to know that, even if you have not installed any app, your friend would have installed those apps, and then using those apps, your friend would be, when your friends are calling you, that particular thing will be scanned by the machine or application there, and they'll be able to identify your number, and hence that's how you get a call. So moving forward, right? Common big data customer scenarios. Now, JP Morgan says is big in using big data. Sears, which I'm going to talk about in detail. Now, why do JP Morgan Chase uses that? They use it to model true risk, threat analysis, fraud detection, trade surveillance, and credit scoring analysis. Now, let me talk about fraud detection. We have, we have 6.5 billion population in the whole world, and at least, let's say, if not billions, there will be millions and millions of individuals using credit cards, right? And those credit card, each transaction made would be stored as one record. And then, how is it possible for someone to even detect fraud? How do they do it? Let's say, for example, your credit card was swiped in New York, and in the next hour, someone swipes it in Washington, D.C. as well. but that's in two different geographical locations. Maybe it takes, even on flight, it takes, let's say, 2-3 hours to reach there. But how is it that someone is using your card from two different places in almost the same time? How do you detect that? Using database or any other analysis or any other analytics, it will be very difficult for someone to find out, because there are millions and millions of customers who want, even if you run a report on them, it might take hours, because you're not dealing with one row or two rows, you're dealing with all rows. There cannot be an application specific to your data set, right? They will have to, if at all, create an application, it has to be generic. So how does someone come to know within 1 hour or even split of a second or minute that your card has been, there has been some fraudulent use of your card? How do you know that? How does someone know that? And how are they able to catch it? So that can be done through big data. Let's go more deeper into the case studies for Sears Holding Corporation. Sears Holding Corporation was using Teradata, Oracle, and SAS, to provide its big data analytics, right? Or for that matter, let's call it analytics. They were doing this, but then they are facing a lot of problems because of their growing data, diversity of data, so on and so forth, right? It's very dynamic in nature. Data are very dynamic. You might have one type of data today, 6 months down the line, you might have different type of data. And business model is changing, right? Once upon a time, it used to be, very simple. You keep notebook and stuff. You maintain, account for each and every individual, and then it went to become website. And then even on those websites, you have customized information for, let's say, 10 million and above customers and less than that. Yeah. So while they were doing this, so as to come up further, the business started changing, and then Sears started facing difficulty, and then that's when they decided to move to Hadoop. And hidden treasures insight into data can provide business advantage. Of course, I mean, there are a lot of things that we might not know, but then the data will tell you exactly. Let's say, for example, if a computer company or, if a computer company has a distribution center, right, and then they are doing analytics on it, or a gut feeling, or for someone as planners and buyers, gut feeling would say that this particular geographical area is doing extremely good business, right? At a 30,000 feet above this, sea level, we might see that say that this particular territory is doing extremely good because I sold 1 million laptops in, let's say, India, right? And then I would be thinking that every distribution center or every shop or every retail shop there are doing extremely well because I have sold 1 million laptops. But then a further detailed analysis on the data would tell us the clear picture. Maybe on the northern side of India, there was on maybe Delhi and its surrounding areas, we had extremely good business, and then we sold 900,000 units of computers there. But on southern India, it was just 100,000. So look at what the data insight can provide you. I mean, by looking at the data, you can say that, okay, fine, maybe my marketing strategy is bad on southern side. I mean, the advertisement that I've been doing in the northern part of India does not work for south, and that's a fact. And then you go and change your business strategy for south, and maybe you would increase your sales, and that's how you increase your business, right? That's how you better your business. So there are a lot of insights that the data can provide. Some key early indicators can mean for fortune to business. Just think about the example that I gave. Some early indicators on the data that I have been analyzing, it can mean fortune to business. Sometimes it's about survival as well. If you are not able to gauge the trend, then you are out of business. More precise analysis with more data. So now also, I have been talking repeatedly about unstructured data, right? What is structured and what is unstructured data. You see this, a meager 10% of 2 petabyte data is available for BI. I mean, this is for Sears Holding, right? And it's the same for the entire data in the world, okay? So they were generating BI reports out of RDBMS. They were aggregating the data, pulling the data from, pulling the data using ETL from your storage, and that's how they were doing it. But look at the analytics they were doing on the data. Only on 10% of the data they were doing analytics, and they're missing out on 90% of the data, which was not structured and were not available in database. Don't you think they were missing out on huge data? I mean, they were missing out on a gold mine. Had they started analyzing this earlier, maybe they would have saved millions of dollars. So moving forward, and then the solution they finally came, the solution which was a compromise between your storage, the databases, and your Hadoop system. So what they did was they started storing all the data in Hadoop system, right? Hadoop storage, and they processed and did their analysis on Hadoop using Hadoop code, and finally the aggregated data was moved into RDBMS, wherein they had some business intelligence report, etc. So there are a lot of beautiful business intelligence report. I mean, Excel sheet is a wonderful business intelligence tool, right? I mean, and 90% of the business users, even as of today, they use Excel sheet. They like using Excel sheet. They have been using Excel sheet for ages now. And then if you ask them to use any other thing apart from Excel sheet, they're like, no, I cannot work on that. So how do you balance out your processing power with your business user? Because at the end of the day, how much ever you analyze the data, if your business users are not comfortable with it, if they are not using the data, if they are not using the data to find a trend, that's waste of time, effort, and money, right? So they had to come to a compromise wherein they used the Hadoop storage, process not just the 10% of data, but complete 100% of data using Hadoop, and then the aggregated data at the end of the day would be very less, right? Whenever you're doing analysis or whenever you're doing analytics on data, at the end of the day, you do aggregation, right? If you have 100 million records, then after all your cleansing and all your aggregation, maybe you'll have 100,000 records, right? So that's moved into RDBMS, and then the BI reports plus interactive app was built on top of that. So that's how Sears moved to a 300 node Hadoop cluster to keep 100% of its data available for processing rather than a meager 10% as was the case with existing non-Hadoop solutions. Now, you must be like, oh my God, they used, instead of one server, they used 300 node Hadoop cluster. Maybe, if I had have used 5 servers instead of one server, this should have done the task for me. I mean, that would be your next logical question, right? 300 node is quite a huge number. So, and you must be like, this is a costly setup. Why would I want to do that? Right? That will be your question. But think of this, right? A powerful server from Dell, HP, Lenovo, whoever sells it, right? A good powerful server costs you more than $1 million. That's a lot of money, right? But if you are processing anything on Hadoop, the 300 node Hadoop cluster, whichever I'm talking about, the cluster right now, here if you see 300 node Hadoop cluster, each of this node is a commodity hardware, okay? Let's say 8 to 16 GB memory or Intel i7, i5, whatever it is, 3 gigahertz processing speed, as good as your laptop. So how much does your laptop cost? $300, $400, and just multiply that by 100. How much does it cost, right? And then, okay, multiply it by 300. That's so much your 300 node cluster cost me. But it's far less than spending, let's say, $1 million in one server, and then let's say I procure 5 servers, which is like $5 million. And here in around $10,000, I can have an excellent Hadoop setup, right? So Hadoop is not just about processing, it's about saving money as well. And that's why companies are interested, and that's why there's so much scope for Hadoop right now. That's why everyone is looking for Hadoop resources. There are not many Hadoop resources available right now in the market. So why move to Hadoop? Hadoop is red hot as is, right? As it allows distributed processing of large data sets across clusters of computing using simple programming model. 1, it is simple programming model. 2, it's simple commodity hardware. And 3, it's very cost efficient. 4, it is extremely scalable. Let's say, for example, you want to increase your database space, right? You are working on Oracle. We would, I'm sure there will be many DBAs here who will understand. And even for others who do not understand, every time you need to add space on your Oracle cluster, you need to bring it down. There is a scheduled maintenance, and then they say that the system will be down for so many hours. We are adding so much of space or so much of processing speed, so on and so forth, right? The scalability is a problem there. In case of Hadoop, it is just one line addition of IP address. That's it. Open a file and type in the IP address. That's it. You're done. You have added that node to a cluster. And then it need not be in same geographical location as well. One can be in India, China, America, Taiwan, wherever you want to. And it has become the de facto standard for storing, processing, and analyzing hundreds of terabytes and petabytes of data. Can you imagine processing terabytes and petabytes of data? I'm sure many of you will be working in big MNCs, multinational companies, and which would be in operation from, let's say, 30, 40 years, or let's say 20 years. They would have so much of data stored for the past 20 years. Right? If you are in manufacturing industry, you'll understand that all the forecasting done, all other analysis done are done on few years of data. It's not even done on 20 years of data, right? Because we actually do not have that capability. The servers do not have that capability to process so much of data, even if it is existent in your database, relational database. It's cheaper to use in comparison to other traditional proprietary technologies such as Oracle, IBM. It's open source. Right? It's free for all. Just go and grab it. Just learn it and grab it. So it's free. And even if you want to use customized solution like Cloudera or Hortonworks or Amazon Web Services, I think it comes much cheaper than the other technologies. And can handle all types of data from disparate systems such as server, log, email, sensor data, pictures, videos. Just think of it. And Hadoop will be able to process the data for you. Okay, so moving on. So here is something from Alice Hill, Managing Director of Dice.com, again a job portal in States. We have heard it's a fad, heard it's hyped, and heard it's fleeting. Yet it's clear that data professionals are in demand and will pay. Tech professionals who analyze large data streams and strategically impact the overall business goals of a firm have an opportunity to write their own ticket. What does this mean? It's highly in demand. Okay, it means that you can demand your money. If you know well, I'm not saying that if you start reading today, you'll be expert tomorrow. I'm saying that if given substantial amount of time, given that if you're guided well, if you're able to execute a couple of projects, learn something in 6 months, maybe you can write your own ticket. Who knows? You can demand your own money, how much ever you want, and that's true. Trust me. As per 2012-2013 salary survey by Dice, a leading career site for technology and engineering professionals, you see, this might interest you. Okay. Out of big three, mobile, cloud, and data, there's one that is having disproportionate impact on salaries. It's big data. Okay. Salaries reported by those who regularly use Hadoop, NoSQL, and MongoDB are all north of 100,000. It starts with 100,000 USD. That's huge salary. Okay. By comparison, average salaries for technologies closely associated with cloud and virtualization are just under 90,000. Many of you might be working on SAP, right? You said SAP is quite in high demand, but is that sustainable? Even if you are working on something which is high in demand right now, trust me that few years down the line that will not be sustainable. If you are just an Oracle professional, it's not enough. If you're just a SAP professional, it's not enough, because technology is changing rapidly. You need to know something. I mean, you need to know big data. Okay, and big data is not one technology. It's a stack of technologies. Okay, and if you want to stay abreast in this industry, you start learning. You'll definitely have to start learning. Now, Hadoop is in demand. Gartner, I'm sure all of you will know, Gartner says big data creates big jobs, 4.4 million IT jobs globally to support big data. Okay, just go and read this after you're through with this session. Now, data scientists fill jobs versus unfilled jobs in big data. Look at the amount of filled jobs. Only 18% of data and data scientists are filled. There's a yawning gap between what is needed and what's there. Supply and demand. There's a huge mismatch. There's so much of opportunity right now. Right now is the time to learn big data. Big data visualizer, same story. Big data research analyst, same story. Big data engineer is tad better because people have started learning, okay, and then while this and also I would like to tell you one thing at this point in time, right? If you know a little bit of big data right now, let's say you become good in 6 months, the type of questions that you are asked in interview, it's actually very silly. It's trivial because everyone is trying to learn, everyone is trying to adapt. I mean, there is no clear picture as yet, at least in India, right, as to where we are heading with big data. So no one knows anything, right? Some people who might be working in big data for some time, I mean, they would know in and out, okay, but the 90% of the population is still learning. So whatever questions they are going to ask you would be bookish. So I would say 6 months to 1 year, even for 1 year right now, you have a lot of opportunity, 4.4 million jobs, plus someone who does not know what to ask, right? So there are high chances that you will crack a high-paying job. But maybe beyond that, there might be tough competition. Big data architect, big data analyst, it's 50-50%. So all I'm trying to tell here is that, look guys, there is challenge in learning this. I mean, it's not that big a challenge if you were to ask me, but I would say if you come from a very diverse background, you might take 3 to 6 months, but that's worth investing your time on it, okay? And right now is the time. There's no better time than right now. And also you see, 2 out of 3 of big data skills requirements are not met due to lack of skilled professional. Only 1 out of 3 big data skills requirements are met. Even if those people are hired, right, they don't know what's big data. I mean, they would have learned something and they would have got hired. All they're doing right now is learning on job. 1 year down the line, they'll all be good. And 1 year down the line, when they start asking questions, I mean, who would have experienced all these problems, they'll ask really tough questions. But right now, if you start it, you might land up in a good place. And this is about salary. Hadoop is way up there. Unix, okay, up above 95,000. Teradata, SAP, so on and so forth, right? And it comes down and down and down. But it's not just here, okay? It's not just here. It's not just 1,10,000. It's much more than that. You can demand it. Mark my word, you can demand whatever you want to. If you are, you do not have to be exceptional. You just have to be good, and you can demand. Apache Hadoop is a framework that allows, let's talk a little bit about Hadoop and big data. I've been talking a lot of about what is big data, what is it that is going to fetch you and stuff. Let's talk about big data. Apache Hadoop is a framework that allows for distributed processing of large data sets across clusters of commodity computers using simple programming model. Okay. The only thing, the biggest thing in big data and the only important concept in big data is understanding MapReduce. Of course, you'll have to write your own code. You might write it in Java, you might write it in Python, or you might just you might not want to write in any other programming language. You just want to use Hive and Pig. That's up to you, right? But at the end of it, at the base of it, the programming model that is used there is MapReduce one, and it's based on functional programming. Okay. If you guys are interested, just go and read about a little bit about functional programming, and you'll understand how MapReduce is actually done. Also, one thing I would like to tell here at this point is, in big data, right, there's huge chunk of data. You might be thinking as to how that is processed. You have so many machines, you have so huge data. Does it go through every machine and then get processed, or how is it happening? That might be the question that you have in your head. The way this data are processed is by virtue of divide and conquer. You just divide the data first, you split it into smaller chunks, fit it into like 300, 500 machines. Every machine is individually processing it, and at the end of it, the data comes to some place wherein those data are aggregated, and that's how you're able to process it faster. Let's say if you were to take some process to be, if you were to process some data in 10 hours and you feed that to 10 machines, just divide it by 10, and the amount of processing time would just be reduced to 1 hour. So that's the power of big data, right? So in many, I have seen the implementation of big data wherein some process used to take 24 hours. In big organizations, there's big data, right? And then some reports take almost 24 hours to generate. I mean, month-end reports and stuff, or if not 24 hours, maybe 12 hours, right? Those have been reduced to mere minutes, 20 minutes, 30 minutes, and so on. So it's really powerful. And best of all, it's open source. You know, you can experiment it the way you want to. Now, these are Hadoop ecosystem tools. There are a lot of tools in Hadoop ecosystem. So let's start from the bottom here. The structured database. You can scoop in and scoop out data from structured database. I mean to say that you can pull the data from structured database into Hadoop distributed file system, or you can push it back to you know, your Oracle or SQL Server or MySQL using Scoop. Scoop is a tool, okay, just for importing and exporting relational data, okay, or structured data. And there is unstructured or semi-structured data can be you know, imported, exported using Flume. Flume is also used to pull the data from Twitter, etc. Okay, I can just run my Flume and then see what are the tweets that are being tweeted right now for Obama or Modi or whoever, Abe or whoever it is, right? Famous personalities. So the administrators would look up to Hadoop distributed file system. They'll maintain here. They'll maintain this HDFS. Initially, the DBS used to look in. You know, they used to maintain the databases, but administrators, I mean, DBS and administrators are equivalent in this case. Administrators, they take care of Hadoop distributed file system. The developers and programmers, they would program in either Hive. Hive is very simple Oracle-like or SQL-like programming language, which internally does MapReduce. Pig is again another language which is called you know, data flow language, designed by Yahoo. At the same time, Facebook was developing Hive. Pig and Hive are very similar. It's just that the way you write code is different. In Hive, it's all select star. In Pig, you know, it's a little different. Load data and then into a relational table, etc. And then Mahout is a machine learning package wherein you can implement machine learning. Now, I'll not talk much in detail about machine learning, but all you can understand is using machine learning, robots are able to intelligently identify many things, or not just that. You know, there are robots which serves as a dishwasher or stuff. You know, everything. You know, all this artificial intelligence, etc., are done using machine learning. So it's not just data. We need statistics, and we need machine learning on top of that. And that's why the Hadoop stack is so important. And then you have MapReduce framework. Like I told you, you know, there is Map and Reduce. Map will split all the data, right? Will split the data into smaller chunks, and Reduce will aggregate those data. And HBase is a database called columnar database, which is used to store MapReduce data. Okay, this has been made for MapReduce. And then Apache Uzi is workflow. If you have worked on let's say Control M, AutoSys, Cron Tab, etc., Apache Uzi is workflow for scheduling jobs. Now, Hadoop and MapReduce. Hadoop is a system for large-scale data processing. We all know that by now, that Hadoop is used for large-scale data processing. I mean, it does not fit well, or it is not suitable for small-scale data. Okay, it has been designed to process large-scale data. It has two main components. One is the Hadoop distributed file system, and second is MapReduce. Hadoop distributed file system, or HDFS, is nothing but you can think of that as a system, okay, which is highly fault-tolerant system, high throughput, you know, suitable for applications that have large data sets and natively redundant. All this means, in one sentence, that the HDFS, if now one more question that might be going through your head right now as to I told you, right, you might have 300, 400 nodes, and then you split the data into each of these individual nodes, and then you process it and finally aggregate it. And these are all commodity hardware, simple, cheap hardwares, right? What happens when any of this fails? What happens to that chunk of data, right? That might be the question that might be you know, in your head right now. So it so happens that Hadoop is wonderful and powerful enough to understand that that particular machine has failed, and so the data will be given to different machines. Or for that matter, there is a concept called as replication factor or replication parameter, wherein each data would be based on a config parameter, let's say 2, 3, 4, 5, whatever it is. By default, it's 3. Okay. A chunk of data, 100 MB of data, is not just written into the main primary machines. It is also replicated into at least 3 different machines. So if one machine fails, the other takes over and then processes it. Let's say, for example, if you are processing 100 MB of data, it's not that the primary machine will start processing the data. The secondary, the tertiary machines, whichever are there as a backup machine, they will also start processing the data at the same point in time. And if at all your primary machine fails while processing the data, the secondary machine, which would have almost equivalently processed that amount of data which the primary would have, is assigned. And Hadoop will be able to identify that instead of going and pulling this chunk of data from this particular machine, I'll pull it from someone else. So it's very powerful. We'll have to go into little detail in order to understand that, which I'm not going it right now. MapReduce, again, I said 2 things, right? Map and reduce. Map splits the data, reduce aggregates the data. Now, the most important concept in all this, right? Every input, every output, every input to map, every output from map, every input to reduce, every output from reduce is a key value pair. Now you'd say that, okay, I passed the test. What's the key and what's value? Or if I have some data like 10 is my key and ABC as the value, then you'd understand, okay, fine, key value. All of you must know a little bit of database. I assume you know a little bit of database. So you know what's the primary key and what's the non-primary key, right? So when I say key and value, you might consider primary key as the key and all other things as value. That's legitimate. You might be like, I just told you that you can process unstructured data, text data, whatever JSON data, XML data, whatever I want. So what's key and what's value there? That might be your next question. So in those things, the key might be something dummy. The key will be dummy. Okay, let's say offset value, some address, right? It'll be some dummy value, and value will be the complete line. Let's say, for example, if this is the data, Hadoop is a system of large-scale data processing, might be value, and then the offset here or some dummy value 0 will be the key here, right? So just remember one thing: everything is a key value pair in your MapReduce paradigm, MapReduce modeling, or MapReduce world. Now Hadoop 2.0, it's so far I've been talking about Hadoop 1.0, right? I've not even talked much about Hadoop 1.0, but there were many lacunas and deficiency in Hadoop 1.0. Like, for example, there has to be 5 daemons. Okay, when you're running Hadoop, you have to have 5 daemons: the secondary name node, job tracker, task tracker, data node, and your name node, right? So these are the 5 things that you have. And task tracker would, job tracker via task tracker would monitor as to what is happening to each of those 300 or 400 nodes, right? But that was a huge challenge for job tracker to track everything. So there has been much more modifications and improvement over your 1.0 version. 2.0 version is much more powerful and much more better in terms of handling all the failures and data related issues. So we have over HDFS, which is Hadoop Distributed File System, there is a layer which has been added on Hadoop 2.0 called as yet another resource negotiator. So we're not going to much more details of it, but as of now, not many companies are adapted to 2.0. Okay, most companies, whoever are using Hadoop, are still in 1.0. But definitely, this is an improvement over the previous version.